transformations. As I've done transformations for quite a while, the first day or two is for some of you can be a little bit overwhelming, especially because we're doing some things that doesn't seem terrible, but then when you get on your own, it's a little bit can be challenging. So let's walk through this format here. This is a little bit what we talked about yesterday. As we get to our last quiz next week, and then eventually our tests, these are the types of questions again that will be thrown at you. So let's take a look on this format. You got yourself a graph already there. This graph has been given to you. It's called f of x. We're starting with that dude. We give you that table. We saw that table yesterday. Okay. In this table, we got the x values, and what we want to do is complete this table. Now, the first column is the easiest one. That is coming straight from what are the y values from there. We've been doing that. When x is -4, where's the y value? When x is -2, where is that particular y value? So let's fill out that first column by just looking at that graph and extracting out those points. Then we'll come around and do the next column in just a second. So when x is -4, all right, where is, excuse me, where is that graph located? When x is -4, what's the y value?
-4.
Thank you. So right here, -4, -4. When x is -2, where's that graph at? The y value? Okay, that sounds good. 0, 0, right? 4, 4. And when x is 6, y is 6. Okay. So that's our basic one. We call that basic one. We call it the parent function. Okay, it's the most basic linear function we can do. Now we transform it somehow. How do we transform it? How do they say to transform it? So it's down there at the bottom, right below that. We saw this notation at the beginning of yesterday. When we started seeing this -4, you're taking the original right here and doing a -4 to that. What does a -4 do to my graph from what we talked about? Go up or down?
Down.
Yeah, down because it's a -4, right? So what we want to now do is take our graph, take those points we just highlighted, and move them down, well, 4 units. So let's do that. This this point right here, move it down 4 units. So we're at, can you count? 1, 2, 3, 4.
-8.
Okay, so when x is -4, the new one is at -8. Emily?
Mine doesn't look like that.
Yours does not look like that. Okay, so I was looking at my copies. A couple of you might have a 2 in front of that, up of X. Does anybody have a 2 in front of that? All right, somebody copied that on yesterday. Let's just scratch it and we'll put it on the board. My bad. We're going to talk about that later on today. So if yours says a 2 out in front, my copies got screwed up. Just let's do what we got here. Do the -4. Just scratch out that 2 and put a -4 there. Okay, as I was saying there, we took that first one, is at -4. We go down 4 because, well, it says a -4. We're at -2. We go down 4 and puts us at, yep, -6. Now we were at 0. We go down 4. We're now at 4. Where you were at 4, and now we're down here at 0, right? And then we were at what? Up here at 6. Go down 4, and we are now at 2. So we can look at this in 2 different ways. Victoria?
Is it really necessary to use a graph?
So I was about to say that. We can look at this in 2 different ways. You can look at it from the graph, or you can also look at it from the table. Both of those are things that we want to be able to say do, because sometimes we'll have just the graph, sometimes we'll have just the table. So it's one of those things we want to make sure you can look at from different viewpoints, okay? Now, from there, what did we just do? When I say describe the transformation, I want you to really tell me, what did we do? Did we go up 5, right 7? What did we just do here? We went down 4. That's when I say describe, that's what I want you to do. So you should be able to tell that from looking at that equation right here, where it said take the original and go down -4. When I say describe, it means down 4 units because it was a negative. If it was a +4 there, we would say we went up 4 units. Now at the end of yesterday, this is where we got to letter C here, putting it into general form. What I mean by general form, keep writing this off to the side. I want it to be in that ax plus b form. Now, what I've given you to start off with is not that form. It looks kind of like it, but it's not. I want to get rid of that f of x and just have an x there. So as we did, and we're going to do some more work with that here today, okay, we're going to take that f of x and look to see what was f of x's original equation, what was its original graph. And at the very beginning of this, at the top, it says, hey, what is f of x? F of x is just x. Yesterday we saw, what, like 2x minus 1 or something like that? Whatever its original equation is, we now want to kind of go and bump that out and replace it with just x. Now yesterday we saw we had some like terms to combine. Is x minus 4, are those like terms? So can't combine them, so we're just going to leave them completely as is. Sorry, and this should be g of x. So that new equation is x minus 4. That's my transformed equation. Now we can do that, kind of like Victoria said, do we have to do that both ways? I want to make sure we can do it both ways. Same thing with the equation. How can I check myself? That blue line that I graphed here, that I transformed, it should be the y-intercept at negative 4. That checks out. And what should the slope of that be? The slope is 1. And are you seeing that nice staircase? That's annoying. Of up 1, right 1, up 1, right 1. That kind of checks out my answer then. Okay. So that's what we talked a little bit about yesterday. Let's flip it to, I think there's a backside now. And my PDF was not working on there. So let's look at that. And if you guys have the combination here. Things combined. Thank you, Richard. The x minus 4 is, nope, 2x. Let's just do a quick show of hands. Because I must have brought two things together. How many people have one that says 2x? How many people have x minus 4 there? Alright. We're going to go look and looks like everybody has, for the most part, the backside. So let's go back to the backside there. Okay? Looks like most of you might have it. Alright, on the backside, because mine PDF does not have that here. Alright. Yours says, excuse me, given each function and then the transform function, it says write the equation in general form and then describe what is happening, what we just did on the other side. So let's just check this out. On that first one, letter A, I give you, I have to write the letter A, okay? I give you what? F of x equals negative 3x. And then I tell you to transform it. So right here, when I say describe what's happening, this is my original. This is how I want to transform it. So when I say describe it, what are you going to tell me is happening here? What we just do on the other side. We went down 4. That minus 4 right there tells me to go up or down. And because it's negative, it means go down 4 units. So let's say that out. Down 4 units. That 4 right there, wherever it's right there where it's located, if it's a plus, it goes up. If it's a negative, it goes down. Now, let's write the general form for that. So we want to get rid of that f of x. We got to go and take that negative 3x, bump it out, and replace it there. So what we're going to have then for b of x, f of x was originally negative 3x. We're going to replace that out, and then we tack on the negative 4. So imagine you could, all right, come around, and I'll try to demonstrate that myself here. All right, I'm going to substitute that in right there, kind of bump it out. And once I bump that out, then minus 4 just falls on down. Do we have any like terms here? No. So then we are done. This is the general form of what I want. Okay. What you're doing is, again, replacing that f of x with what was originally given, writing the new equation. How about the next one there? Now, the next one we're going to lead into in just a few minutes today. I think we might have saw a little bit of that yesterday, but I think we'll see it more here in just a few minutes with our notes. Okay, this time I have another 4 up there, right? But the 4 is not in the same location, is it? All right, at the end of that, that's either moving it up or down. But out front, we're getting multiplied by it. So as we're going to see here in just a few minutes in our notes today, what's going to happen here is we're going to say it's going to be let me just write it out and we'll talk about it in our notes. A vertical dilation by a factor of 4. What the heck do I mean by a vertical dilation by a factor of 4? Well, let me show that with you on Realist real quick with Desmos, assuming it opens up here. Give me a second. So what we have to start off with, the internet's not working very fast today. Well, that's not helping me. Try this again through this way. I think we should just go home. Internet's crapping out on me. What's that, Victor? Patience. Well, you see here, there's a problem with that. Oh. Yeah, shut up. All right. So, as I type in the original, what was the original on there? 2x, right? The original is 2x. We get a nice linear graph. We apply what we call as a vertical dilation. We're going to see what that does. So we're going to take 4 times 2. What's 4 times 2 give me? 8. It's going to give me an 8x. So when I hit the x now, it's going to give me a new graph. And let's take a look at what it does compared to this original one. When I hit the x now, we get this blue graph going. And what would you say is happening more with this blue graph now?
Steeper.
It's definitely much steeper. So what we say is it's a vertical dilation by that factor 4. And what it's going to do, because it's that 4, it's going to, what we kind of say is stretch it out, make it more steep compared to the original. So the graph that we create then, because this never opened, is going to be right here, that 8x. We replace out that g of x right there, and our new equation is this here. So when you multiply something, think about it. You multiply something by 2, you double it, right? You multiply something by 3, you triple it. What are you doing? You're making it larger, right? So that's what's happening on our lines. When we multiply that by a 4 or a 3 or something like that, what's going to happen is it's going to start growing a little bit more quickly. Which of these two, I wouldn't like to walk up either one of these. Which of these two graphs would you rather walk up? The one in red, right? Not easy, but I'd still rather attempt that one than the vertical one, right? So when you start multiplying that by that number, what happens then is it gets a little bit more steep. Now on the flip side of that, we haven't got to the other one. Give me a second. What if instead I had that as a 2? What if I made that 1/2? Okay. Sorry, leave that as 2. 4 is what I was changing. Try this again. Right here. I meant to say this is 1/2. So if I took that 2 of x again and plug it in, what's half of 2? What's half of 2? 1, right? So if I type in half of 2, which is 1x, what do you think is going to happen to that graph? Get steeper or get less steep? It's going to get less steep. So I just typed in 1/2 of 1. 1/2 of 2 is 1. And when I put that x in there, that graph went down a little bit.
So when that number is like a half, it's going to make it not as steep, a little bit easier for you to walk up on. So what we're going to look at today is what that 2 and what the half, that 4 out front, what it's doing that's having its impact on our graphs. All right, let's look at the bottom question there. Last one here, kind of what we were doing. What type of, excuse me, what happened on number 3 here, letter A? I give you again that original graph, which is what? The original function is 3x. I transform it to this. So my question to you is, again, what is happening here? Going up by 7. So as we start seeing from yesterday and then today, when you have a number here at the end, that is moving my graph up or down. So here we say it goes what? Up 7 units. How about on the second one there, letter B? I start off with negative 3x. Then I want to take that thing and transform it by writing this. So what's going to happen with that graph? It's going to go down because that 1 at the end is a minus 1 and not at the end. So that's going to go down 1 unit. So where these numbers are located, that influences how that graph transforms. There's only really 2 things you got to keep in mind. If it's a plus minus at the end, it goes up and down. And as we're about to see today, when there's a number out front, it's going to either make it more steep or going to make it less steep. Those are the only 2 things you got to keep in mind. Now, to finish this off, oh, I already finished off, never mind. We just said transformed what? Up 7 units, and then the bottom we just did what? Down 1. Okay? So let's continue with that. Let's go ahead and get out your notes. Let's pick up where we left off. 40 something, assuming? 47 says Ms. Keenel. I think that's the page. I think we did, yeah, 3-2. Is it? Or did we do that? 3-2.
Well, we start off with 32.
Yes, we are there too. Yep. 47, M2-47, everybody. M2-47. Give you a minute here on that. M2-47. So let's go ahead and keep talking about what's going on here. Okay. Again, a second. So what we just talked about in our warm-up leads us nicely right into our notes for today. Okay. So let's put those again, phones off to the side. Move them a little bit here. All right. Yes, we're in page 47. M2-47. Okay. So here's again what's going to happen. I'm going to give you some type of graph to start off with. Most of the time, the graph that I give you is the original f of x equals x. And then we want to do some type of transformation to that based off what's being described. You should be able to tell me what happens, and then what is that going to look like. So on that M2-47, that's what they've done for us. They gave us this original graph. They highlighted some points here like we did yesterday. And now, right here, we want to change that by a factor of 4. So what they mean by a factor of 4 here is what we just did on our warm-up a second ago. Get back there, okay, is to take that original and multiply it by 4. Okay, so when they say change it by a factor of 4, that means multiplication's happening there. That multiplication's happening at the very front. 4 times f of x. So let's do that because we all can multiply nicely here. We're taking that f of x column and multiplying by 4. So negative 2 times 4 is? So let's plot that point out there. We start off originally at negative 2, we multiply by 4. We're now down here at negative 8. All right, let's multiply by 4 again. We're at negative 1. Negative 1 times 4 is? So we were originally at negative 1. We multiplied that by 4. We're now down here. Okay, we multiply by with 0. 0 times 4 is, no, that doesn't change anything. Then we are at 1. Multiply that by 4. 1 times 4 is, okay, so we are at 1 multiplied by 4. We're now up at 4, like you said. And then lastly, we're at 2 multiplied by 4. So we were originally at 2. We multiplied by 4. We are now at 8. Take your ID. And just like we saw in the warm-up a second ago, what happened to my new graph? That new graph got steeper. Now yesterday, we didn't play around with that steepness. What was that geometry word we talked about yesterday? When we did these, all the slopes were the same. And we were creating lines that were parallel. But now when we start playing around with that steepness, we are actually changing the slope around. So today we're going to look to see what that slope is, what's happening to that slope by changing that number out front with a 4 or a half or a 2, whatever you end up doing. So let's do letter B, like we've done before. Identify the slope and the y-intercept of our new function here. Anytime we keep saying general form, I want that ax plus b with you, okay? I need to know what the slope is. I need to know what the y-intercept is. That's not the first time we've done it. We're doing the new function. So how can we do this? You can play that slope game, okay? Take those nice points that we highlighted right there. How much are you going up? How much are you going over? Make those steps, okay? You can look at the table. We've got a whole bunch of different viewpoints from here. We can look at the table. How are we changing on the table? Okay. There's going to be a lot of different tools we can use to get to that same result. All right, so how much are we going up here? 1, 2, 3, 4. And we're going to the right. Well, duh, what do we just multiply by? Multiply by 4, right? Right here. How much are we changing by? -8 to -4 is a, -4 to 0 is a, -2 to -1 is a, -1 to 0 is a, and how do we write that up? 4 over 1, which is also just, because that factor was 4, what we did was multiply the slope of 1 by 4 to get 4x. And that y-intercept is where it crosses the y-axis. So the new one that we did on my board, it's the red one. Where's the y-intercept on the red one? Right here. Where else can we see it? It's right here in our table. Remember when we said when x is 0, that's code for I am the y-intercept. Look at me, I am special. All right? So do we have to put a plus 0 there? No. What do we usually just say? Yep. We just usually say 4x. Okay? So that's where we want you to be at. Hopefully by the end of tomorrow I'll be a little bit more better at that. Okay? Transforming things and writing that final equation. All right, let's keep going on here. Do we have anything at the bottom? Nope. Let's flip it to the next page. Same setup, and that is an ugly number to work with of 2/3. So we're not going to use 2/3. Let's change that, scratch it out. I want you to do a transformation of a half. That's a little bit nicer to work with. Scratch out that 2/3, and let's work with it as a half. So, same thing's happening, right? I've got this original f of x equals x. That's my basic one. Now we want to go ahead and multiply by a factor of a half. So we're going to take, we're going to take that f of x and multiply it by a half there, okay? So let's do that, just like we did before. Take those y values, multiply by a half. You all can divide by 2. So let's do that. We start off at -2. What's -2 times a half? What's -2 divided by 2? Yeah, -1. So -1. Okay, not as nice of a number, but -1 divided by 2. What's -1 divided by 2? Yeah, it's -1/2. Can't take 1 divided by 2 nicely, so we'll leave it as a half. Now, you have to just kind of eyeball that -1/2 a bit. All right, we're at 0. What's 0 divided by 2? That didn't change. What's 1 divided by 2? Okay, back to a positive this time though. And then what's 2 divided by 2? And we go what? 2 comma 1. Take your ID. And as we saw a few minutes ago on our warm-up, if I'm multiplying by a half, what happened to the slope of that line? You got a little bit less, right? Because this red one, I'd rather walk up that red one than the original one, because that slope changed here by a factor of a half. So what it did was made it not as steep. That's what that 1/2 does out front. Now, do we do anything with moving them up and down at all yet? That was yesterday. What moves you up and down is if you have something at the end of that. We don't have anything there, so we're not moving up and down. I think we'll combine those two things in just a moment. Now, let's finish this off. Write me the equation again of that new function we created, sorry. So it's b of x equals the slope plus the y-intercept. So what is the slope for that b of x? Yeah, it is a half. How can we find that out? We can find it out from doing our steps. We can find it out from our table. We can go and do some steps right here. Up 1, right 2, up 1, right 2. That checks out. Table, not as stellar because we got some fractions in there, but it's going back to that, correct, that 1/2. Where is it crossing the y-axis at? Where is my y-intercept located? Still at the origin. We haven't moved that thing up or down. This is the y-intercept right there. And one more time, do we need to say 0? We can just say 1/2 x. Okay? We can do that, then you're okay. All right, give you a second. I've got a few people still writing. Let's keep walking through here. So we've seen 2 locations, a number out front, a number at the end of it. One moves up and down, the other one changes the steepness. Okay? Now, we have anything else on that page? Nope. So let's flip it to the next page. And on the next page, one thing we have not done yet is multiply by a negative. So let's do this last one here. It says multiply it by a factor of -4. The ones that we've seen so far have been multiplying by a positive for a positive 1/2. So what happens when you multiply by negative? Changes, not necessarily changes to positive, but it just changes its sign, right? Negative times a negative is positive, but a negative times a positive times a negative is negative. So let's do that. Let's take those numbers again right here for the y's, multiplied by -4. So what's -2 times -4? So let's go plot that. We are down here at -2 to start off with. We multiply by -4. We're now up here at 8. What's -1 times -4? Okay, so we're at +4 now. What's 0 times anything? That didn't change. What's 1 times -4? -4, yeah, duh. And what is 2 times -4? -8. So when I look at this graph, take your ID. Whoops, I cannot graph correctly. I screwed up that one right there. Okay, take your ID. What happened here? On all these so far, what have eyes been doing? On all the other ones, our eyes have been going up. They've been increasing, right? And what just happened with our new graph here? It's decreasing. And what obviously had the impact of that? It's multiplying by that negative. Now, in math, what we say here is, we say it was reflected over the x-axis. So we reflect this over the x-axis, we flip it on that, okay? So in math, that's what we call a reflection. Now, let's bring it together here. Let's write the equation like we've been doing. Ax plus b. Gotta have the slope, gotta have the y-intercept. So this time, what is my slope? How can I figure out that -4? Confirm it. Can do my steps, yep, very quickly, going down 4, right 1. I could do it from my table. If you got all that going, that works too. There's more than one way to look at those. And then what is my y-intercept located? Has that changed yet? Unfortunately not. That's my y-intercept. And I've done it 3 times now. Do we have to put the 0 there? No. And that is my new equation. You all know math is about repetition, so let's keep with that, okay? Now, I'm not caring too much about letter C here on that bottom part, okay? So let's go to the next page here. All right, now let's kind of bring everything together, okay? So this is where we're kind of getting ready to end some of this talk, where we bring the 2 days together. What we did yesterday with what we did today. Our goal by, I said, either end of today or tomorrow is for you to look at these and tell me what is happening. How is it being transformed? What number does what? So let's look at letter A. All right, what's that 7 doing? I'm sorry? Yeah, let's usually say up or down there, yeah. So we're saying that 7 in that location, a +7, let's tag it. It says it goes up 7 units. Now, we just saw the 2 today. That 2 out front. What's that 2 doing? That is changing the slope, correct. That's changing the steepness of my line. Now, how do we write that in math vocabulary? Okay, right. We say it's a vertical dilation, and unfortunately, I don't give you enough room to write there. Vertical dilation by a factor of 2. Please put that by a factor of 2 there. If you just say vertical dilation, I don't know what number you're referring to because there's always multiple numbers in there. I want you to say, what are you doing? You're doubling this thing. So if you're doubling something, isn't that kind of making it larger? And therefore, it's increasing the slope, correct? All right, let's look at letter B. What are we doing on letter B then? Describe what's happening there. Down 1 and get a vertical dilation by a factor of 3. So let's literally state that out. If I could write the word down. Down 1 unit. And then the other part is vertical dilation by a factor of, now a 3, think of tripling something. It's gonna triple it. And what's a triple do compared to double? Triple is more, right? So that slope is gonna get even steeper. Not quite vertical, but it's getting a lot more steep. Tell me what the 1 does, tell me what the 3 does. That's what I want you to be able to tell me. Okay, what about letter C now? What is C doing? That's the quick one. Tell me what it's doing at the end there. Up or down? Yeah, it's up 2. All right, so we're going to say up 2 units. And then a 1/3 out front. Let's think about it a second ago. What happened to that 1/2? Did it make it more steep? What did the 1/2 do a couple pages ago? It made it less steep, right? Now we still say it's a vertical dilation by a factor of 1/3. Okay. And I'm gonna, after we get the letter D done, come back and talk about these 4 dilations in a second. I want to throw out one more new math vocabulary term out there. That's half the problem. It's a lot of math vocabulary out there. What's the last one they're doing on letter D? First thing is that quick down 3. And then we follow up by saying again a vertical dilation by a factor of and then come around here and give you 2 math vocabulary words. Give you a second so everybody's on the same page there. And let's talk about these 4 dilations. All right. So as we were working here, I was asking you, does it make it more steep or make it less steep? And what do we say up top there for the first 2? The 2 and the 3, doubling it and tripling it. Does it make it more steep or less steep? Makes it more steep. What does the third? What's the half going to do? Make it more steep or make it less steep? Less steep. So in math, what we call this dilation, we're going to throw out a new word up the top there. It's a vertical dilation, but because it's by a factor of 2 and by a factor of 3, what we say is happening here is, if I can spell, we are saying it's a stretch. Okay? Both of these are what we call in math a stretch. When you double something, all right, think of maybe like a rubber band. Start to keep pulling it, stretching a little bit, doubling it in size, tripling in size, it's stretching out, right? So as we do that with that linear equation, we keep doubling it, tripling it, we're taking that line and stretching it out. Now, we're not doing any stretching on the other 2, because these went more steep, we're kind of stretching it out. Here, we're kind of making it, what? A little bit more, as I keep rotating my pen a little bit. Not as steep, a little bit flatter, right? When we multiply by a third, by a half, it's not as steep, it's making it a little bit flatter. Now what we call that in math, I think of CPR. I'm pushing it down, what am I doing? Chest compressions, right. So when we call that in math, we have a compression. I think of CPR and doing compressions here. And when we make that graph less steep, we say that there is a vertical compression happening there. So again, you've done CPR class and you do those chest compressions, you keep pressing down on that chest. That's what we call a compression. You're making it a bit flatter. That's my 2 last vocabulary words to throw out there for you. Okay. Now, I know there's a lot of vocab going on the last 2 days. We'll keep talking about that tomorrow. Let's look at the other page real quick, and we'll call it a day. We'll come back to this tomorrow. I want to do the same thing here with you on letter E and letter F. Now, when I look at letter E here, what's the first thing that should jump out at me? Down 4. It's a -4 at the end. That's the quick one. We're going down 4 units. Am I doubling anything on this one? Am I tripling anything? Quadrupling? Multiplying it by half? 1. When you multiply by 1, does that change anything? What's 1 times 5? Still 5. 1 times 6? Still 6, right? But what happens when I multiply by a -1? It turns negative or it turns positive, right? It becomes its opposite, right? We just did that a few minutes ago on one of the previous pages. We multiplied by -4, right? What did that do to our graph when we multiplied by -4? I said it did a reflection. So, let's state that. Reflection across the x-axis is what we say. That's what that negative does out front. There are, I said earlier, 2 things happening. I lied. There's 3 things happening. If there's a negative out front, that does one thing. It reflects over the x-axis. Did I say that on the other 4 on the previous page? No, because there was no negative out front. We're going to get the exact same graph. It'll either be steeper or less steep and moving up and down. Here, though, on this one, we're going to graph these tomorrow. We're going to get a graph that looks like that. Don't draw that in. Okay? We're going to get a graph that looks like that. Then, at the end of that, if we have a number there, we're either adding or you're either going up or down. Now, on the last one, letter F, what's the quick one again to say? Down 5. Oops, sorry, yes. Kept saying use down. Yeah, we're going up 5 because it's a plus, correct. So we're going up 5. Now, what else do I have happening here? There's a negative out front, right? And we just said the negative influences the graph to either be increasing or decreasing. So we say it flips it. So I'm going to highlight that negative like I did earlier. And we phrase that as reflection across the x-axis. Half of the problems with math is learning that vocabulary. That's what we're doing here today. We talked about the 5, we talked about the negative. The only thing we have not talked about is the 2/3. So what does a 2/3 do, you think? Is it going to make it larger or make it smaller? It's fraction skills, that's a problem. Anybody have thought? Larger or smaller? Okay, so there's x. So if I type 2/3 x in here, what's going to happen? Now I hear smaller. When you say smaller, you think it's going to make it steeper or less steep? Does that happen? Maybe. It did, right? So that 2/3 made it a little bit less steep. So what does that mean? Did it get stretched out or did it get compressed? It got compressed. So we're going to take that 2/3 and say right there, vertically compressed by a factor of just say the 2/3, because we already took care of the negative, right? What do we say the negative does? Reflects it over the x-axis, okay? So when you say vertically compressed or vertically stretched, don't take the negative with it, only take the positive of that, 2/3. That's what we're looking at today. Tomorrow I'll get a little bit better with things off there. We kind of thrown everything out there almost, all right? So if I bring all that together, which we're going to do that tomorrow, I did the 2/3 with you, okay? And if I put that negative out front, where's the negative sign? There it is. It reflected it over the x-axis, so it's decreasing. And what was the other thing, a +5? What's a +5 say we do? It says we said it should move it up 5, and it did. It moved it up then 5 units. So we want to break down all those pieces, talk about them, and then can you bring them all together at the end, okay? All right, that's where we'll pause our notes. We'll finish these up tomorrow, okay? So let's get out the assignment for you. Let's do a couple of those together like we've been doing, and then you'll have some time to work on your own. All right. Let's take a look here real quick. Everybody a second, get situated. So you're going to see this keep happening, so on and so on, with our assignments for the next couple of days, leading to next week. Okay? I'm going to give you a graph to start off with. I'm going to give you a partially done table. I want you to complete that table, tell me what was happening. We just talked about that a second ago. When I say describe the transformation, I want you to tell me up 5 units, a vertical stretch by a factor of 10, a vertical compression by a factor of 1/3, stuff like that. That's what I mean by describe. So let's look at this first one together. All right, we are starting off with the graph that is called 4x. I want you to identify off the original graph, when x is 0, where's the graph at? So when x is 0, where's that graph located? 0, 0. When x is 15, where's the graph at? And as I keep talking and doing those, kind of modeling of what I'm doing in my head, highlight those points at the same time. Draw your attention to those points as I keep working through that. When x is 30, y is at 120. When x is 45, we are at, so that is where we are starting off at. Now, what are we going to do to that? So we're going to now graph twice the original, okay? We want to double w of x values there. So we want to take and double the ones that we just found. So before I even do that, you should be able to answer out part B. When I see 2 times that, think back to our notes a second ago, what does that 2 out in front do for us? Yeah, it changes that slope. It does not go up and down. It changes that slope, and that slope is going to become more steep. So what we say then is it's a vertically, now do I say stretched or compression here? Yeah, because when we double something, I think of keep expanding it out, stretching it out. So we say it's vertically stretched by a factor of, and tell me that number. Yep, 2. So I know if there's multiple numbers on here, I know which number you're referring to. So let's do that. Let's multiply those by 2 now. What's 0 times anything? So we still got 0. What's 60 times 2? 120. And this is a place where your calculators come into play. 120 times 2. 180 times 2. 360. Can we plot those out? Not all of them. I think we get a few of those on there. So let's go plot that first one. 0, 0. Same location. 15, 120. 30, can I get 240 on there?
Yeah, it's the top one.
Is it the top one?
Mhm.
All right. 30, 240. Can we get 45, 360 on there? Definitely not. No big deal. We got enough. Take your ID. Make the line. Now, a second ago, we said it becomes vertically stretched. The slope should increase, be more steep, and it checks out. And let's finish this off in letter C. There's that general form, ax plus b. So what did we do? We took the original times 2. Now, what is the original? Is it just x? What was the original, the given right here? So we took the 4x and doubled it. So what is 2 times 4x? 8x. So the equation for our new guy that we just made is 8x. Now, like we've been doing, how can we check that out? Doing the steps on my graph is possible, or going from the table is possible. Okay, got some large numbers to work with, but if I go and use my good old handy dandy calculator, what is 120 divided by 15? It better be. It does check out. Okay, so a whole bunch of different ways we can do that. Sometimes it's nice from the graph, sometimes it's nice from the table, sometimes it's nice using the equation as well. We can do that. We're very happy. Getting there, I know, can be a little bit, take some time, but you'd be good to go then. All right, I'm going to leave you on number 2 to try your own. All right, let's take a look down here at the bottom of number 3. Let's do A together, and then we'll do another one together here. On 3A, what we just did a second ago, okay? We want to take that original graph, 2x, and what does this say we want to do here? When you read this transformation, what is happening on this transformation? It's a +5 at the end, and a +5 or a -5 at the end goes up and down. So when I say describe it, all right, I want you to tell me, yes, up 5 units. Cool. Now write the equation. This is where students, again, always kind of get tripped up on. General form is ax plus b. Replace that 2x right there for the f of x. We did that just up above a second ago. 2x plus 5. Are those like terms? So we are done. And what do? We took the original equation, 2x, and went up 5 units. Okay. All right. Let's look at number 4 down below. Let's look at letter A. Same thing. On letter A, tell me what is happening here. I give you 3x. What does this transformation right here tell me to do? It's a minus 5 at the end, and down 5 units. Okay, that's it. Can you read the notation? Let's put I'm going to do another one right below that. Let's put the letter C on there. What if I give you this one? If I could write. Okay, what if I give you that one? What's that 3 up front telling you to do? Not going up. There you go. It's changing my slope, right? It's making either more steep or less steep. So we say it's either going to be vertically stretched or vertically compressed. So that number of 3, I think of tripling it. I think of doubling, tripling it. I am stretching it out. So if I gave you one like that, we would say vertically, yep. Hey, Grace, have a seat right there and I'll get you, okay? Vertically stretched by a factor of 3, correct, okay? All right, once you get that, flip it over to the next page, and let's see on the back side, is there anything of the new stuff that we talked about, or is that old stuff? All right, on the back side we go. All right, what do we got? Oh yeah, as you said, old stuff. Okay, so this is nothing new. We've done all that work before. Let's spend just a few minutes here while we got it. What are we selling again? We're selling still some peppermint hot chocolate. I think yesterday we were doing $3, but we're giving away, yeah, we were giving away 10, but we're not doing that today because we're at a away game. And what we have to do when we're at an away game? You gotta rent the facilities of the other team. Do they usually give that away for free? Not usually. So we have to lose what? $100, right? So let's set this thing up, and we're selling what? Cups of hot chocolate. Cups of hot chocolate. Okay. And what do we keep talking about making here? EFC is representing our money made, right? Our earnings, as we say. Now, again, you're in charge of the Booster Club here. How do you plan on making this money? Selling hot chocolate, but what do you also have to account for? Losing how much money? Losing 100. So we've done plenty of these. How are we making that money? $3 a pop, right? $3 for every cup of hot chocolate sold. That would be great if we're at our home game. That would be our equation. But we're not. So what do we need to do with that 100? Just like we give away freebie stuff, and we got to pay to use the facility. Yep, that's a minus. Okay. That equation now drives our problem. Let's label our x and y axes. Again, that's coming from the C and the E of C. X-axis is always the independent quantity, and that is our what? Cups of, yep, cups of hot chocolate. And then our y-axis is still representing our earnings, right? So that's stuff that we did at the very beginning of the school year. Now, it says identify the point that represents 36 cups of hot chocolate sold. And how much money did we get when we sold 36 cups of hot chocolate? That's not a lot of money. Why is that? Because we gotta pay $100, right? So 36 cups of hot chocolate only gets you $8. And as Chloe said, It's because we are having to rent this out. We gotta sell a lot of hot chocolate. Come back with $8, probably not good enough, right? So 36 cups gets you $8. All right, let's go up on the top there. What does 200 then mean? Sold how many? And made how much? Sold 200 cups and made something. 3 times $200, or not 200, $3 times 200 minus that. This is again your calculators come into play. Okay, we all know what 3 times 2 is 600, right? And 600 minus 100 is not only, but it is $500. When you sold that much money, it's probably worthwhile being at the game. We came away with only $8. Probably not a good idea to next time sell hot chocolate at every away game. Now, how much do we need to break even? Break even is $100 worth, but how many cups does that translate into? So that's at 0 we keep talking about. 0 is where you break even at. You're no longer in the negatives, but you're not in the positives yet. Breaking even is at that 0. So that's the equation we've been setting up, just like with letter F. We want to make $400. How many cups of hot chocolate do we have to sell for $400? It's the same thing, but when we say breaking even, you've gone out of the negatives, you're at 0, you're not in the positives yet, almost. That's what it means to break even. Get back to 0. Finish it, Grace? Okay. You're quite welcome. So from there, let's use our equation skills. Let's solve these out. 2-steppers is all we've done. 1 and 2-step equations is all we've reviewed. Second semester, Ms. Kino and I are going to hit you with 3, 4, 5, 6 steppers and go on from there. But you all be able to solve a 2-stepper like that. On both of these, let's solve them together. We're getting rid of that 100. The inverse of minus 100. This is where your calculators for your arithmetic might be nice to have. So we get 100 there. Now on the other one, we're solving these at the same time. We get $500. Now here, when we get ready to divide by 3, because it's 3 times and the inverse of multiplication is division, we're going to go to our calculators. We are not going to get nice numbers. We cannot take 100 divided by 3 nice, nor 500 divided by 3 nice. So let's think about our rounding game. 100 divided by 3, what do I round that to? 33 cups or 34 cups? 34 as I'm hearing. If you say 33, this is going to be a multiple choice type question. Because if you select 33 times $3 a pop, do we get to that $100? We're off by $1, right? So this is where we need to kind of change our rounding skills and realize, hey, we need to round that thing up to 34. 34 cups. So what about the $500? $500 divided by 3. We need to round that to 167 cups. That gets you your $500 or $400 that you wanted to make. Really, it's 500 because you got to get back that $100 because of the rental fee. Again, this weekend is now finally the craft show. So as the crafters will come here on Friday night, Saturday morning, set up, they've had to pay an entrance fee to rent out the space here. So they got to recoup that renter's fee right there. All right, last one there is number 6. We've seen that one before. I want to finish off number 6 with you down here at the last question though of. We just talked about that today with our graphs. Use the graph to determine when f of x equals -4. So go to the y-axis at -4. Find me that point and tell me what its x-coordinate is. So when I say this dude right here, f of x equals -4, graph is located right here. Tell me its location. That location is 3, -4. So x equals what? X equals 3. Okay? X equals 3. Got to go to the y-axis on that one. But if I go back above, doing out of order on purpose here. For you guys to again see what does it look like, what do I have to find. When I say evaluate f of 1, now that time it means, hey, when x is 1, what is y? The way it's phrased does change up where you start off with, either on the x or the y. And because of that one, start with x is 1, and what is that location? 1 comma 0 is what I want. 1 comma 0. That's what we've been doing. That is not new stuff. That's all old school. Okay. Now, at the bottom, what we have left is some solving equations work. Okay. On that solving equations, we've talked about this before. I just want to keep on your toes. On letter A, we have parentheses. What do we have to do to get rid of parentheses? Yep, we got to use our distributive property. So as we use our distributive property there, negative 2 times 3 and negative 2 times negative 2. Once you get rid of parentheses, this is no different than what we just did up above. This is a two-stepper. Subtract 4, divide by negative 6. It should be an automatic knee-jerk reaction. That's 5th and 6th grade. I'm not trying to slam anybody, but you should be up to speed by 5th and 6th grade here on solving our two-steppers. Letter B is the exact same thing. Okay. Now in letter B though, what freaks kids out is that division, that fraction. Who the heck cares? Just like here, we're going to subtract 4. Here, we're going to start off by not adding 1, but subtracting, because it's a positive 1. We're going to subtract it. Watch your arithmetic. Use your calculator if you need to. Negative 9 plus negative 1 is negative 10. And what is the inverse of division? Right. So just keep asking yourself those questions like I'm doing out loud here. When I ask what's the inverse of plus 1, you say minus 1. What's the inverse of division? You say multiplication. Now I'm not just going to multiply by 3. What's in front of there? So I'm not just multiplying by a 3, I'm multiplying by a, right, because there's that negative out front. Cancels out. There's my x. And on the right hand side, watch your arithmetic. Negative times negative is a correct. Okay. Those are the two-step skills you got to have mastered by now. If they're not, you've got me, Miss Keelan. You've got 13 days. So get things figured out. When we come back in January, we're going to run right off that. 3 steps, 4 steps, 5 steps, 6 steps. Get you up to speed then. Okay. Let's finish it off. You got about 15 minutes here. Okay. Let's finish off this assignment. If you get it done, you can turn it in tomorrow. Got 15 minutes. Let's get going here. Okay, we'll keep working on things.